Right, this is how you differentiate sine fifth 3x. That of course means sine 3x to the power of 5. So I find it quite helpful at times to write it like that. And then the chain rule says if you've got a bracket to the power of 5, when you differentiate it, it's 5 times that bracket to the power of 4. But then you need to differentiate the contents of the bracket. So the contents of the bracket are sine of 3x. So if we differentiate sine of 3x, sine differentiates to cos. But then we've got to differentiate the 3x. It's a bit like there's another bracket there. And if I differentiate 3x, of course, that's 3. That's a bit of a messy way of writing it. There's a 5 and it's times by 3, so that's 15. Sine 3x to the power of 4, the proper way to write that is sine fourth 3x, and then the cos 3x. Here's a second question where we've got a quotient. It's 2x plus 1 divided by 3x minus 2. So I've got to differentiate that quotient. So the rule for differentiating a quotient, u over v, is you differentiate the top one first, differentiate the bottom one second, and it's over the bottom one squared. So if I differentiate the top one, it's 2x plus 1, differentiate that, that's 2, and leave the 3x minus 2 alone. And then differentiate the bottom one second, so that's 3, and leave the top one alone. And then it's all over the bottom one squared. Let's tidy things up. 2 times 3x is 6x, 3 times 2x is 6x, 6x minus 6x is nothing. 2 times minus 2 is minus 4. And then minus 3 times plus 1, that's minus 3. All over the bottom one squared. So altogether it's minus 7 over 3x minus 2 squared. Here's the third question. How do you differentiate a ln? Well, it's 1 over the ln bit. It's not a very precise mathematical way of saying it, is it? But there you go. So it's 1 over 2x cubed minus 5x squared. And then you need to differentiate the bracket. It's a chain rule question. Differentiate the bracket. So and we're going to get 6x squared minus 10x. And that's it. Now let's differentiate a number like a to the power x, and the rule is it's a to the x ln a. A special case of that, because this is for any number like 2 or 73 or anything like that, is e to the x. So it's e to the x ln e, but ln of e is 1, so it's e to the x. So this is a special case of this general formula, which you just need to remember. Now, if x equals tan y, if I differentiate tan, I get sec squared. This tells me what dx by dy is, but if I wanted to know what dy by dx was, it would be 1 over sec squared y. And 1 over sec squared is obviously cos squared. On the next slide I'll go through all the differentiation that you need to know about trig functions. I'll just give you the table, so here we go. So these are the 6 main trig functions: sine and cos. Tan, remember, is sine over cos. Cosec is 1 over sine. Sec is 1 over cos. And cot is 1 over tan, or cos over sine. And then when you differentiate sine, you get cos x. Differentiate cos x, you get minus sine x. Differentiate tan, you get sec squared x. Differentiate cosec, you get minus cosec cot. There's cosec cot. Differentiate sec, you get sec tan. And differentiate cot, you get minus cosec squared. And this table you have to learn. And if you're not absolutely sure, remember that tan you can write as sine over cos. Cosec is 1 over sine. Sec is 1 over cos. And cot is 1 over tan, which is obviously also cos over sine. So you need to remember that. Now integration is the inverse of differentiation. So this question is asking us what function do we differentiate to get sine 4x. So let's try differentiating cos x. If I differentiate cos x, it's minus sine x. So that's no use, because I want to get sine 4x. So let's differentiate cos of 4x. So that's minus 4 sine 4x, because you need to differentiate the 4x, which comes out like that. So that's nearly pretty good. What happens if we differentiate minus cos 4x? Well, cos goes to minus sine, so the two minuses cancel out. That minus with the minus you get from differentiating. Differentiate 4x, that's 4. So now we know that if I differentiate minus cos 4x, I get 4 sine 4x. And that is the same as this. So therefore the answer is minus cos 4x plus c. So this question is asking us which function is it that we differentiate to get sec 3x tan 3x. If you go back to the table, you can see that if you differentiate sec x, you get sec x tan x. So if you differentiate sec 3x, you're going to get sec 3x tan 3x, but then you have to differentiate the 3x. There's like another bracket there. Differentiate 3x is 3. So if I differentiate a third of sec 3x, 3 times a third is 1, and I get sec 3x tan 3x. So the answer to this question is 1/3 sec 3x plus c. And this question is very similar, because if I differentiate cosec x, I get minus cosec x cot x. So if I differentiate cosec 2x, I get a 2 there and a 2 there, but then the 2 comes out because I've got to differentiate the 2x. If I differentiate minus cosec, then minus times a minus is a plus, so therefore the answer is minus cosec 2x plus c. Check by differentiating. Let's just go through that again. If I differentiate cosec goes to cosec cot, the 2x goes forward, but then differentiate the 2x, I get a 2, but it's minus cosec cot, so that minus and that minus cancel out.